All right, who's ready to do some math? That's what I thought. Everyone. All right. Back to rational number operations, the first part of this unit. Yesterday we looked at adding integers and rational numbers. That is, adding negative and positive numbers, both whole numbers, decimals, and fractions. So I really hope that you took the time to make those rules for addition feel good, because you're going to need them again today. Even though we did adding and we are moving on to subtraction, addition plays a role, at least in the way that we teach subtracting rational numbers here. So I'm going to go through the lesson today. If you can remember, yesterday we talked about the basic vocab: integers, positive, negative, whole numbers, rational numbers, any number that can be written in fraction form, which includes whole numbers, fractions, and decimals. Great. And then yesterday we went through 3 different scenarios. We talked about the rules for adding integer. We said scenario 1, if both numbers are positive, do this. If both numbers are negative, do this. If one number is positive and one is negative, then this is how it works. Well, we're going to do something similar. Rules for subtracting integers. Scenario, always. There's only one way that I'm going to go through subtracting integers. You can learn this a lot of ways. Like, people can really overcomplicate this or try to teach you some clever slogans or blah, blah, blah. Don't get sucked into that. What I'm about to show you, very, very simple. And more importantly, it works for every single subtracting problem that involves negative numbers. So the rule that I'm going to show you is, if you have a subtraction problem, change the subtraction to addition. That is the rule. Change the subtraction to addition. And then you will have an addition problem, and you are going to follow your addition rules as you normally would, the rules that you learned yesterday. So, what does that even mean? How do you change a subtraction problem into an addition problem? Well, let me tell you, every single subtraction problem in the world has an addition problem that is related to it. And let's look at that. How do you do it? 3 simple words, my friends. Add the opposite. And I'm going to explain what that means with a very simple example. So we all know the answer here. 10 minus 7 is 3. What I want to go over, though, is what is the addition problem that is related to this? Well, the way that you can find its related addition problem is I'm going to write a little arrow. We're going to turn this into addition. How do I do that? I'm going to add the opposite. I feel like we're on a game show. All right, so add means add. So I'm going to change the subtraction to addition, and I'm going to add the opposite. So what's the opposite of 7? Right now I'm subtracting 7, but instead of subtracting 7, I'm going to add the opposite of 7, which is negative 7. So what's 10 minus 7? We all know that. 3. What's 10 plus negative 7? It's 3. Well, if the answers are the same here, then that means this subtraction problem, 10 minus 7, is the same thing as 10 plus negative 7. That means these two problems, the subtraction and the addition, are equivalent. Every subtraction problem can be turned into an addition problem by following this simple phrase: add the opposite. So you do not touch the first number. The first number is always going to stay the same regardless of what it is. You don't touch that. We are going to add the opposite of the second number. So whatever the second number is, we're going to turn it into addition and then just change it to its opposite. So in this case, the number was 7, and the opposite of 7 is negative 7. Let's look at that in a different example. We're here to play add the opposite. So I'm going to change this subtraction problem into addition, add. Now let's look at the original number. The original number is 12, and its opposite is negative 12. So now, instead of trying to think about this subtraction problem, however, forget it. I have an addition problem. An addition problem that will yield the same answer as whatever that subtraction problem would yield. So no matter what, I'm going to get the same answer. It's just instead of trying to learn some extra rules for subtraction, just turn it all into addition because you can, and then you only need to think about how you add integers. So 3 plus negative 12. When the numbers are different, you subtract them. So 12 minus 3 is 9. And then you go back to the numbers and you say, all right, which one has a bigger absolute value? Well, the absolute value of negative 12 is 12, and the absolute value of 3 is 3. This one has a larger absolute value. Therefore, my answer is going to take its sign, which is negative. Since 12 was negative, my answer is negative. You could also think about it in terms of money with the debt. We talked about that. You can use integer chips. There's more negative chips than positive chips. Therefore, my answer should be negative. You can use a number line. You can even use a number line, to be honest, for subtraction, right? You could say, all right, I'm starting at positive 3, and it says minus 12, so I'm going to move in the direction of subtraction, which is backwards, right? Or not backwards, to the left. And how far am I going to move to the left? 12 spaces. So, and if you move 12 spaces, you'd eventually end up at negative 9. But in reality, you're not going to sit there and pull out a number line every time you want to add or subtract numbers. It is a good way, though, to start to grasp the idea of how the numbers are moving and where they are in a number line. That part of it's good, but you can't just rely on the number line forever. All right, some more examples. Let's do it. Math. Example 3. I've got negative 8 minus negative 13. And we're going to play add the opposite. We're going to turn this subtraction problem into an addition problem. So the first number just stays the same, negative 8, and then it becomes addition because we're going to add, and then we're going to look at the last number and add the opposite of it. So the opposite of negative 13 is positive 13. So now I have a nice addition problem, but this addition problem is the same as this subtraction problem. They will yield the same answer. We already proved that in example 1. It's true. That's how it works. So negative 8 plus 13, since I've got one of each, one positive and one negative, I'm going to subtract them. So 13 minus 8 is 5. And then how do I know if it's positive or negative? Well, the 13 has a larger absolute value than the negative 8. And since the 13 is positive, my answer is going to stay positive. All right, last example on this page is 5 minus negative 4. So I'm not going to touch the first number. I'm going to change this to addition, and then I'm going to add the opposite. So the opposite of negative 4 is 4. So this weird looking 5 minus negative 4 is the same thing as 5 plus 4, which is a super easy problem, right? 5 plus 4 is 9. And there's your final answer. And also, this problem, example 4, is a good example to highlight why using a number line might be challenging at times, right? What does it mean to subtract, but then subtract negatively? Like, I could explain that to you. It might not make sense, or it might be hard to grasp. I feel like just changing the problem to an addition problem is a simple way to understand how to subtract integers. Just know your addition rules and you're good to go. Cool. So we're going to end today, very short lesson, with just an extra example. Try to put this in context. I've got some data shown in this chart. So North America, the continent that we live on, it has an elevation of 6,198 meters, and that is the highest elevation in North America. Its lowest elevation is negative 86 meters. That means it's below sea level by 86 meters. Now, if you look at the continent of Africa, its highest elevation is 5,895 meters, and its lowest elevation is negative 155 meters. My question is, which continent has a greater range? Ooh, range. It's from last unit, data and statistics. So to find that, remember range is the distance from one part of the data set to the other. Like, what's the spread from negative 86 up to 6,198? What's the spread? How far is it from negative 155 all the way up to 5,895? Well, you could put it all on a number line and try to count thousands of spaces, but that seems silly. Or, what is range? Range is the difference between the greatest and the smallest values. So let's set that up. The difference for North America, that would be 6,198 minus negative 86. Biggest number minus the smallest number. And then for Africa, that would be 5,895 minus negative 155. All right, and now when I have subtraction, as I had just gone over, the trick is change it to an addition problem. Add the opposite. So 6,198 plus the opposite of negative 86 is positive 86. And over here, 5,895, add the opposite. So the opposite of negative 155 is positive 155. So now I've got these subtraction problems turned into two very nice addition problems. That's not difficult addition at all. 6,198 plus 86 is 6,284 meters. And what that means is the spread between the lowest elevation to the highest elevation is 6,284 meters. And over here in Africa, the spread from the lowest elevation to the highest elevation is 6,050 meters. So which one has a greater range of elevations? By a little over 200 meters, it would be North America. North America is greater in range of elevations than Africa is, based on this data. All right, that's your lesson for subtraction today. You've got, 12-ish practice problems. I challenge you to take your time and rewrite each of these problems. Don't just do it in your head or plug it into a calculator. Take the time to learn and train your brain appropriately. So write the subtraction problem and then rewrite the problem as an addition problem. And then use your addition rules. Really try to ingrain this in your brain. This is, like I said, a major part of how you're going to start your 7th grade year, and it's only just going to go faster. So take the time now to get it. You've got time at home. You've got this video that you can rewatch. You've got us that you can ask questions to. You've got Google Meets that you can join. If you need more resources than that, by all means, reach out to us, let us know. Otherwise, have a great time learning math. Woo! Bye!